Hello, and today we're going to look at inequalities. This will be a review of inequalities. And inequalities are not that difficult because you're used to solving you're used to solving equations. Now you're going to solve inequalities. And I'll explain the difference in just a minute, but I'm going to go ahead and write down the rules that you have to remember. Here they are. These two guys, you need to remember everything you can about these four symbols. Okay? These two, and you notice I'm not saying what they are because it depends on the context of the sentence. Okay, and I'll show you that in just a minute. These two guys are represented by an open circle, parentheses, and if you draw on a line, a dashed line. The word that goes with these is exclusive, meaning that you do not include the number. You exclude the number. The number is not equal to that number. In other words, the solution set does not include that number, and I'll explain that in just a few minutes. These two guys have the equal sign. So remember, and I'll highlight the equal sign on it, so therefore you will hopefully remember that these two guys are inclusive. So that means they get a filled in circle if you're on a number line, or a set of brackets if you're writing an interval notation, or if you're graphing on a two-dimensional graph, they get a solid line, and the word that goes with these two is inclusive, meaning that you include the number. Now, that is what you have to remember with inequalities. So I'm going to put that, I'm going to take this little section, and I'm going to move it up to the corner, and we're going to make it smaller, and you're going to write it on the index card so you will remember it. The reason people don't do well during inequalities is because they don't remember those rules. They choose not to remember those rules, so when they do a problem, they don't know how you get the problem or why it's wrong. Okay? Now, you haven't given us any method. No, there's no method, because you'd solve just like you've always been solving. Now, a while back, when I introduced to you solving, I always try to keep the variable positive. Now, there's a reason for that. Try to keep the variable positive. 90% of the time you can do that. And I'll show you what happens when you don't do it. And I'll show you what to do. All right, so with that being said, and I'm going to highlight that because I think that's very important that people understand. If you want to make life simple for yourself, try to keep the variable positive. All right, here we go. Now, you're used to doing this type of problem. 2x plus 4 is equal to 6. And you subtract 4, and you subtract 4, and you get 2x is equal to 2, and you get x is equal to 1. And you highlight that, and then you feel good about yourself. What does that mean? That's the only number in the world that will plug back into the problem and get a true statement. That's why it's called equal. That's why it's called an equation. This is an equality. Meaning that this is the only number that will work. You cannot plug in a 5. You cannot plug in a negative 1/2. You cannot plug in. The only number that will work in this equation is 1. And that's what you've been doing up until now. So let's take that and let's move that over here and just put that in your memory bank. And say that's the way we used to do things. Now you got an inequality. The inequality gives you a solution set. It gives you a solution set instead of a solution. It gives you a solution set, which means a lot of numbers that will work. So let's take the same problem and let's do this. 2x plus 4 is greater than or equal to 6. Now, notice that I said, okay, that's greater than. Yes, but I could easily say 6 is less than or equal to 2x plus 4. Or I could say 6 is less than or equal to 2x plus 4. So, you know, trying to give this a name without any context is kind of like trying to figure out the meaning of the word when there's no other words around it. So I don't call it a name when it's over here. Okay? When it's over here, I just put it up there and say these two guys and these two guys. Now, when I have a context, I say give it a name. So that's what I was going to tell you. You don't have to name it. You don't have to say, oh, this is less than and this is greater than. No, you don't have to do that. Now, I'm going to solve it just like I always do. -4, 2x is greater than 2. X is greater than or equal to 1. Now, this is what we call a solution set. Before, we had one number in the whole wide universe that would work. Now we got more than one number. How do you know? Well, you're going to graph it. Graph it on a number line so you can understand it. Zero, 1, 2, 3, -1, -2, -3. This arrowhead's called negative infinity. This arrowhead's called positive infinity. Okay, so let's graph it. X is greater than or equal to 1, so we take a closed circle and we put at 1. Well, Hubert, how'd you know a closed circle? Because if I've got one of these, I use this stuff over here. So a closed circle. And what numbers, somebody tell me what numbers are greater than or equal to 1? And everybody should say all the numbers to the right, Hubert. That's right. Which includes positive infinity, because that's the name of that arrowhead. So, there's two ways to write your answer in equalities. There's two ways. So I'm going to move this up a little bit. Why did it do that? Hold on a second. I know why. Okay, I'm going to move this over. And I'm going to erase all this. There we go. And I'm going to rewrite. There we go. Now, the two ways to rewrite this are set builder notation and interval notation. Set builder notation, you write a set of braces and you put X such that, and then you put your answer right here. Your answer is right here. So write X is greater than or equal to 1. And that's called set builder notation. So you need to write in your index card where you have this This right here on your index card, you need to write set builder notation, and you need to highlight this because this is set builder notation. That's set builder notation. And interval notation is what I use and what a lot of algebra teachers use interval notation because you read from left to right. So let's read. You read shaded from left to right. Okay, so here we go. We looking left to right. Where do we hit the shaded region? Boom! We hit it at 1. And then we go to what? Infinity. And we put a bracket here. How do you know that, Hubert? And what do we put on infinity? Infinity always gets a what? Infinity always gets, negative infinity always gets a parenthesis, and I'm going to put that in red so you'll remember. Always get a parenthesis on negative infinity and positive infinity. Why? Well, somebody tell me what infinity is. Give me a number. You can't. You can't touch infinity. So that's why it gets a parenthesis. The bracket is a bracket because it's inclusive. And this is called interval notation. So, and let's go over here and write infinity and negative infinity get parentheses. So you need to write that down too. Okay? And that's how you do inequalities. So we're going to do another one. And I'm just going to erase this part. I'm going to erase the answer here. I'm going to erase that. And erase that. I'm going to try to, I guess I'll just erase this. And erase that. Okay, so now I'm going to do 3x minus 2 and 2x plus 1. There you go. Now, pause the video, and what I want you to do is I want you to solve it. I want you to graph it on a number line, and then I want you to write it in set builder notation and interval notation. And it's a good practice for you to get in anytime you do a homework problem is to do all 4 of those. Solve it, graph it, put it in set builder notation and interval notation. So pause the video and work that problem out. All right, let's see how you did. I'm going to make my variable positive, so I'm going to keep that, take it across the river, and I get x minus 2, and take that 2 across the river, and x is less than 3. So I'm going to graph it. That's positive infinity. That's negative infinity. 0, 1, 2, 3. Negative 1, negative 2, negative 3. And I'm going to graph 3. So I take I'm going to use a blue marker, and I'm going to graph 3, and that's going to be an open circle on 3. Why? Because you know your index card right here. And what numbers are below 3? So I take my highlighter. What numbers are below 3? Now, set builder notation, braces. X such that, and what's my answer? X is less than 3. And that is one answer in set builder notation. And then the next interval notation, read the shaded region from left to right. Negative infinity to 3. You can't touch infinity, and you can't touch 3. Why can't you touch 3? Because it gets parentheses. And that is interval notation. So, in summary, 1, solve. 2, graph on a number line. 3, set builder notation. And 4, interval notation. And if you can do that with any of the questions on the homework or anything like that, then you should be okay for the test, whether it's a placement test or whether it's a standardized test or whether it's a chapter test. Now, there's 2 other things I want to show you about inequalities. One of those things I told you, some of the time you won't be able to keep the variable positive. And I don't go over this very much because you don't have to worry about it very much except for these certain problems. I teach keep the variable positive. Now, there are a few problems that you cannot keep the variable positive. Negative 2x is less than or equal to or greater than or equal to negative 5 and less than or equal to positive 10. This is the type problem where you can't help but the variable is negative. So, well, I tell you what, I'm going to change it. I'm going to change the middle because I'll be able to cover another problem if I do that. Oops. Didn't want to do that. There we go. I'm going to change the middle a little bit. And I'm going to make it 2x, negative 2x. Oh, me. Okay. Negative 2x plus 1. Okay, now my x is in the middle, so I got to get rid of that positive 1. So that means I've got to subtract 1. If I do it here, I've got to do it here and do it here. So that gives me negative 6 less than negative 2x less than or equal to negative 11. Now I have to divide by negative 2. Now here I'm going to put this in red because this is going to change something. Whenever you multiply through or divide an inequality by negative, not only does it change the signs of the numbers, it also flips the inequality. So it's not only going to change this to a 3, this to an x, and this to a 11 halves. It's also, I'm sorry, that's not a negative 11. 10 minus 1 is 9. I called it. Okay, so that's going to make negative 9 halves. Not only does it change the signs in blue, because this is a positive, this is a negative, this is a positive, but it also, and I'm going to do this in green, it also flips the inequality. And that is your answer. And of course, you graph it like this. Positive infinity, negative infinity, 0, 3, what is that, negative 5 halves, or negative what, 4 halves, 4 and a half, negative 4, or negative, that's negative 4, this is negative 5. Okay, so I'm going to plot 3, and it gets a closed circle. And negative 4 and a half gets a closed circle. And what numbers represent set builder notation, I'm just going to put an X right here and such that in braces. That's set builder notation. Interval notation, read the blue shaded area from left to right. -9/2, comma, 3, bracket, bracket. And that's what happens when you have a negative exponent. That's why I choose not to deal with negative exponents unless I have to. So I'm going to leave that on the board there for a second so you can pause the video and let it sink in a little bit. Now there's one more thing I want to show you on inequalities, and it's pretty minor, but it's having to do with directions. Sometimes you're going to see directions and it's going to have integers. Now remember what we talked about with integers in our whole numbers, and integers are whole numbers. That's negative and positive whole numbers. So we cannot include the fractions and decimals that are between the whole numbers in the set. What do you mean, Hubert? Well, let's say the directions are up here and it says solve the, and it'll say integers. You got to read the directions. When it just says real numbers, you can deal with, that's what we've been doing. We've been doing real numbers, but when it says solve for the integers, we can take the same problem, 2x plus 3 greater than 5, minus 3, 2x is greater than 2, x is greater than 1. And set builder notation would be x such that x is greater than 1. And we're going to graph it. And this is where you got to be careful. This is negative infinity. This is positive infinity. 0, -1, -2, -3, 1, 2, 3. And there's 0. Now, since this says integers, just cross that out and put over it whole numbers. We can't include fractions and decimals. And fractions and decimals are in between the whole numbers. So we can't just shade the whole thing. We just have to shade the whole numbers. So how do you do that, Hubert? Well, what number? First of all, let's locate x is greater than 1. Well, that's all the numbers greater than 1. We cannot include 1, but we can put a dotted circle around here. That's an imaginary circle because we can't hit the fractions below 1 and above 1. We can't include those. So it just is an imaginary open circle there. It's not even there. And then what numbers are greater than 1? Well, that would be 2, 3, and infinity, but we can only include the whole numbers through infinity. So what we do is we put 3 dots right here. That means all the whole numbers to infinity. And your interval notation would be 1 to infinity, close, and you would put 3 dots right here, and those 3 dots means whole numbers. So it does not include what's in the middle, it just includes the whole number. So that's something you have to watch for. Make sure you read the directions and make sure if it says integers, you cannot include the fractions and decimals that's in the middle between the numbers. And that is your review of inequalities.